Good morning, everyone. In this session, it is the continuation of the last class. That is, we are discussing about the problem-solving agents, and we also discussed some toy problems. In this session, I'm going to discuss the other some problem types, and with the help of AI, how we are going to solve the particular problems. In this, the very first and foremost important problem is water jet problem in artificial intelligence. So, what do you mean by this water jet problem? Here, we have given two jugs, which is one is 4 liter and other one is the 3 liter. And neither of the any of the jugs has measuring markers on it. And there is a pump that can be used to fill the jugs with water. Now the question is, how can we get exactly 2 liters of water into a 4 liters of jug? So in 4 liter jug, we want exactly 2 liters of water. So how we are going to solve this problem? So here, any problem when we are discussing with AI, that representation should be in the form of a state space search. Hope you remember in the last class we discussed this state space search. So any problem in terms of artificial intelligence, we are going to represent in the form of a state space and search. So here, what are the states? States are nothing but here X and Y. So where X represents the quantity of water in a 4 liter jug and Y represents the quantity of water in a 3 liter jug. And that X we can represent it as 0, 1, 2, 3 or 4. Means still 4 liters we can fill water in this 4 liter jug and Y equal to either 0, 1, 2, 3 till 3 liters of water we can fill. And then what is the start state and what is the goal state? Initially, the start state is 0, 0. That means we have an empty 4 liter jug and empty 3 liter jug. The goal state is we should have compulsory 2 liters of water in 4 liter of jug. And here it can be N. That means anything, either it may be 0, 1, 2 or 3. Any of these values can be N. So this is our start state and this is our goal state. And this is how we are going to represent this particular water object problem in terms of state space and search. So before going to that, we have to frame some of the valid rules that can be used to solve this problem. The very first one is we can fill the 4 liter jug. That representation will be something like this. Okay. X less than 4 and 4 comma Y. This 4 represents this X. Okay. That is 4 liters. Similarly, we can fill the 3 liter jug. And also we have some other rules like we can pour some water out of the 4 liter jug, that is X minus D. This D represents some water we can pour out of this 4 liter jug. Similarly, we can also pour some water out of the 3 liter jug. So these are other rules. And we can empty this 4 liter jug and we can also empty this 3 liter jug. And when there is an empty in this 4 liter jug, we can pour water from the 3 liter jug into 4 liter jug until the 4 liter jug is filled. Suppose in 4 liter jug, we have only 3 liters. So in such situations, we can take some water from 3 liter jug and we can pour it into 4 liter jug. That is what this rule states. Similarly, the same rule. We can pour water from the 4 liter jug into the 3 liter jug until 3 liter jug is full. And we can also, other rule states that we can pour all the water from the 3 liter jug into the 4 liter jug. Similarly, we can pour all the water from the 4 liter jug into the 3 liter jug. And last two rules, we can pour the 2 liter water from the 3 liter jug into the 4 liter jug. Why? Because why we are saying that according to our problem, we are defining the rules. And we can empty the 2 liter in the 4 liter jug on the ground. So these are the some of the rules we are going to frame for this particular state space search problem. And here the solution. Let us see how we are going to write the solution for this water jet problem. The start state, we know that it is 0, 0 and loop until the goal state 2, 0 region. And here similarly, we have to apply a rule whose left side matches the current state and set the new current state to be the resulting state. So this is the solution. And let us see this solution. Start state, we already said that it is 0, 0. Now, as per the rule 2, see these are the rule 2, okay, fill the 3 liter jug. So the same thing. Rule 2, fill the 3-liter jug. Now it becomes 0, comma 3. And rule 9, pour all water from the 3-liter jug into the 4-liter jug. Yes, we have pour all these 3 liters into 4 liter. Now it become 3, comma 0. Now rule 2 says that again we are using the rule 2. We are going to fill the 3-liter jug. Now the state has become 3, comma 3. Now rule 7, pour water from the 3-liter jug into the 4-liter jug until the 4-liter jug is full. I already told you this rule. Now, as there is 1 liter empty here, we are pouring some water here. Now, this is full. So, we can say that it is 4 liters of water. And as we moved 1 liter from here to here, we can say that here it is 2 liter. Now, rule 5, empty the 4-liter jug on the ground. Yes, we are emptying this 4 liter. Now it will become 0, comma 2. And rule 9, pour all the water from the 3-liter jug into the 4-liter jug. So now this 2, we are pouring it into 4-liter jug. Now it has become 0 and it has become exactly, we brought 2 liters of water into the 4 liters of jug. So this is goal state we reached, so we can stop the process. So this is how we are going to solve the water jug problem. Here the important thing is not only how we are going to solve this one, the way you are representing in the form of a state space search and applying the valid rules, and how we are going to describe the solution is very important here. Okay, you have to make use of all these formulas, all these rules, and then you are going to write this solution. Now, similarly, we'll discuss one more problem, that is missionaries and cannibals problem. This is also one of the important problem in AI. So here, there are two persons, that is missionaries and cannibals. Okay, and a boat. There is one boat to them to move from one bank of river to the other bank of the river. Initial state, all objects are near river bank. So here, operators can be, we can move both with ex-missionaries and Y cannibals to other side. Before going to that, let us describe this. What is the problem here? See here, on one bank of a river, 3 missionaries and 3 cannibals, and there is only one boat that can hold up to only 2 people. And they have to cross the river. And if the cannibals ever outnumber the missionaries on either of the river banks, the missionaries will get eaten. So now the question is, how can the boat be used to safely carry all the missionaries and cannibals across the river? Okay, so here the condition is cannibals ever outnumber the missionaries. Okay, so here the initial state is shown to the right here, where the black triangles represents the missionaries and red circles represents the cannibals, and these cannibals should not be outnumber the missionaries. This is one of the conditions. So here we have to frame the rules similarly like earlier. Okay, rule 1, some rule 10 rules. So here you can just pause for a minute and just read the rules. What rule 1 says, that one missionary sailing the boat from bank 1 to bank 2, one missionary sailing from the boat from bank 2 to bank 1. So here 2 missionaries from bank 1 to bank 2, bank 2 to bank 1, and one missionary, one cannibal, one missionary and one cannibal, 2 cannibals, 2 cannibals, one cannibal, one cannibal. Okay, these are the, here when we are framing the rules now, it should not be outnumber. That condition, they all in problem already it's mentioned. In that way, we have to frame the rules. So see here, the start state, okay, the persons in the bank 1, we have 3 missionaries, 3 cannibals, and in the bank 2, no one is there, and the boat position is at bank 1. So, as per the rule 5, 2 missionaries, 2 cannibals, means one missionary, one cannibal can travel to the bank 2, okay, and one cannibal will come back, one cannibal will stay in bank 2, and one missionary will come back. Now 2 cannibals will move. Now one cannibal will come back, and one missionary will move. Okay, now see here again, one cannibal will come out and one missionary will move. Likewise, if you follow all these steps, means all these rules, by the condition they have given, that the condition given that cannibals ever outnumber the missionaries with the with these conditions, okay, and with these rules, just see what are the rules we have followed, and at last the start state we have reached to the goal state, and the bank and the board position is at the bank too. Okay, this is how we are going to solve the missionaries and cannibals problem. Just learn, just pause for a minute and see how this one missionary, one cannibal, or two cannibals, or two missionaries, how they are traveling and how they have safely reached with the condition given to the river bank. Thank you.